Today, we have a Chunlan brand unit, a company whose monogram resembles GRI, but it is a separate company based in China. Today, we have its floor-standing inverter unit, which has come in for repair. However, in this video, we will learn how to wire this 2-ton floor-standing unit. So let's provide you with all the information. Right now, you can see that the outdoor unit has been opened easily because it only has 2 screws, so it's not much of an issue. This black strip here is its display, and below that, you'll find its panel and blower motor. Now, I'll show you how to open it step by step. Now you can see that an attempt is being made to push it, but it doesn't open. For this, you need to have a tester or any flat tool. What you need to do is insert it like this and gently push it, and it will open. Do the same on the other side as well. See, with a push, it has come out. The cover has been removed, and now you can see its electric panel along with the blower motor and other components. Next, we'll open the panel and explain how to do its wiring. For units like this, the wiring can be done in 2 ways, from the indoor unit to the outdoor unit, or from the outdoor unit to the indoor unit. However, the best practice is to always connect the main cable to the load, and since the heavier load is on the outdoor unit, you should always use a heavy-duty wire for the load. This has 2 benefits. 1. Reduced electricity bill. A heavy wire ensures efficient current flow, minimizing energy loss. 2. Increased component lifespan. The smooth flow of electricity reduces the chances of damage to the compressor PCB and other components, thereby extending the unit's overall lifespan. Now let me show you the unit. Look here, the L and N connectors are installed, and this is the main cable going inside the PCB. We have connected the red and brown wires. The red wire goes to the indoor unit, while the brown wire is the main wire. Similarly, the white wire is also going to the indoor unit, and the blue wire is our main neutral wire. Lastly, after connecting the earthing wire, the connection will be complete. Now take a look at the indoor unit. The connections here are similar to the outdoor unit. Make sure to use good quality wires here as well, because the indoor unit also handles a heavy load, especially when it operates in heating mode. Notice the N terminal with a comma. This also indicates the neutral wire. A loop is installed here, and the neutral wire is connected back to the terminal marked with the comma. The reason for this is that this unit has built-in heaters, and this is the neutral connection for those heaters. The control phases for the heaters are managed by the PCB using relays. Next, I'll show you the connections for these relays. Now, the neutral wire has been routed inside, and the main line and neutral are connected to the L and N terminals, just like I showed you earlier in the outdoor unit with the red and white wires. At this point, these connections are complete. However, the communication wire is still not connected. Let me now show you where the communication wire is located and how it fits into this setup. I've now found the communication wire. Take a look at this connector, XP103. This is the connector through which the indoor and outdoor units communicate with each other. Notice the red and black wires. You also need to connect the red and black wires to the outdoor unit. Now let me show you which connector is used on the outdoor unit. Look here, this green connector, labeled XP209, is the communication connector. You simply need to connect these 2, indoor and outdoor, using the communication wire. Make sure to connect the red wire to the red and the black wire to the black. Now, let's talk about the connections on the indoor unit's PCB and how it operates. You can see a transformer here, which indicates that this PCB doesn't use an SMPS, but instead relies on a simple power supply system. Here's how it works. The input to the transformer comes through this red connector, labeled XP113. This is the main supply for the PCB. The supply is fed into the transformer, which outputs 12 volts. These 12 volts are used to power the relays and other components. Then, the voltage is further stepped down and converted to 5 volts for the PCB's control circuitry. This is how the PCB operates, providing power to different parts of the unit efficiently. Now, take a look at the main supply wires. 2 wires are coming from the main supply. 1 wire is used to operate the PCB. The other wire is used to operate the heaters. You can see that these 2 wires are connected separately for their respective functions. Additionally, notice the blue relay installed on the PCB. This relay is specifically for the heater. The wire for the heater goes down, as shown, and the brown wire is its main supply. The other wire coming in is for powering the PCB itself. This is how the system works, with separate circuits managing the PCB and the heater efficiently. Let's discuss further about the connections. The capacitor installed here is for the blower motor that runs inside the unit. There is a 4-wire connector connected to the 6-wire motor, which powers and controls the motor's operation. Additionally, there is a red-colored connector connected to the thermostat. This thermostat is specifically for the heater installed above. When the heater gets overloaded, the thermostat shuts it down as a safety measure. This is installed as a protection mechanism. All other connections are connector-based, making the setup very convenient. The use of connectors ensures that connections are made correctly since they are color-coded and precisely sized, preventing incorrect wiring. Similarly, in the outdoor unit, connections are also connector to connector, maintaining the same simplicity and reliability. This is how the entire system operates efficiently. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.